Hey everybody, Heather Herenstein here today to talk to you about the physics of Assassin's Creed. To start out, Assassin's Creed is labeled as a historical fiction action-adventure open-world stealth game that is set in the past. The earliest game, Assassin's Creed, is set in the time period of the Third Crusade, and the series branches across the Renaissance to colonial times. While the game contains historical figures and real-life architecture, it has been criticized for its lack of realism and sometimes glitchy gameplay, both of which strangely make sense when the physics system comes under scrutiny. I'll begin with the basics, gravity. Since gravity is used in a wide array of physics equations, the natural first step is to determine whether or not Assassin's Creed gravity follows earthly gravity. I took some cues from game theory and duplicated their experiment to determine the approximate gravity of each of the following Assassin's Creed games. As you can see here in Assassin's Creed 1, we have just finished climbing up a tower that has been modified from a real-life model, and we are now it's just diving off. Let's look at the equations behind it. Here we can see that all things equal, the physics should even out, and if gravity is earthly gravity at 9.8, then the first number would equal the second. However, we can see that this is not the case, and thus must take further action to determine what exactly Assassin's Creed the First's gravity is. Moving the equation around, but retaining time and distance established previously, gives us a gravity of approximately 11.164 meters per second squared, which is obviously greater than Earth's gravity. Having established this, I'm moving on to Assassin's Creed 2. Assassin's Creed 2 is similar to the first in many ways, but it has seen some graphical improvements. The question is, has its physics improved? Is gravity closer or farther away to Earth's? Through the same process that we used to find the first gravity, we can obviously see that the gravity is in fact more extreme. Using, again, the same process, same equation, we can find out that Assassin's Creed 2's gravity is a whopping 15.3632 meters per second squared. Very nearly double that of Earth's gravity. Let's jump ahead to the most recent installment in the Assassin's Creed series, Assassin's Creed Black Flag. This game has you taking the role of a privateer turned pirate assassin, and the graphics have made leaps and bounds over its predecessors. Granted, there are still some minor glitches, but instead of focusing on those, I'm going to focus on a key and fundamental part of the game, its water. The protagonist hails from Britain this time, and he goes by the name of Edward Kenway. He lives for money, fame, and not much else. Hold up. Did he just dive 40 feet in relatively good form into a 5-foot pool of water and knock him more than a few inches below the surface? What's going on here? After all, as we can clearly see, someone in lighter physical condition and someone who is falling a shorter distance has a full second less of hang time and takes nearly 3 times as long to come back to the surface after they've gone under. Is it the water? Is it him? Some possible theories for this phenomenon are an increased water density in this Assassin's Creed universe. But that doesn't make sense, because he quite obviously swims to the shore with no evidence of excess strain or effort. Perhaps our hero is just unusually buoyant or extremely durable, as he's hitting the water with an average velocity of 17.283 meters per second. Next in the water theme is the truly ultimate leap of faith, made possible one of the itty-bitty glitches I mentioned earlier. This gentleman is falling feet first from a casual 416 meters up in the air into water, staying submerged for a mere 2.11 seconds, and swimming with marathon swiftness to the dock. Any other individual would most likely be crushed upon impact, not to mention be affected by all of the water resistance they'd encounter, decked out in a leather trench coat, 4 guns, a sword, and a leg potentially broken on the ship's mast. To put that kind of speed in perspective, hitting the water from that kind of fall would put you at 90.297 meters per second. That's over 200 miles per hour. Any normal human being would have been crushed. The conclusion we can make from this statement? The newest Assassin's Creed defies physics just as much as the older ones do. Is there anything in these games that follows the accepted laws of our universe? Yes, in fact, there is. Debuting in Assassin's Creed Brotherhood, a Renaissance-era game, the parachute designed by Leonardo da Vinci is structurally sound. It was tested and confirmed working in 2000 by a daredevil named Adrian Nicholas. The parachute design itself is silk stretched over wooden beams, but one used in the games is essentially the same, just more collapsible.